We're in business. Everybody see it?
Yeah, looks good.
Good. All right. So this is the presentation that I was going to give right before I left FAA, actually. The plan was to do a presentation outside of the FAA, and then the FAA pretty much stopped a lot of the outward discussions as the new administration came in, so I didn't get a chance to do the presentation. So it's a little bit dated, but I'm going to try and update it with the latest information I have as well. And it's more my presentation than anything else than the FAA's, but commercial space transportation was instrumental with all the information that's in this presentation. And so credit to them for helping me put it together some months ago as well. So real quick about what we're going to talk about tonight, the space ecosystem and commercial space activity, which is beyond just what the FAA does. But we'll talk about what the FAA's role is in that, the statutory authority, why we did what we did, why we do what we do, and who else is involved besides the FAA, the differences between the offices in the agency, having spent 17 years in the agency, and then the safety benefits, other players. And I added some sections on key takeaways too, because there's so much going on in the space economy. So by 2030, it's going to be $1 trillion. And I think it's a low estimate. If you look at the cost per kilogram to put objects in space right now, it's coming down drastically. And this is because of companies like SpaceX and Blue Origin and Rocket Lab and so many others that are out there that are now finding more affordable ways to get material into space. So as that space price per kilogram comes down, the accessibility to space goes up, the interest in commercial space goes up, and then we have an ever expanding market. So up to $1 trillion by 2030 and overtake aviation by 2033 to 2040 in terms of economic impact. So it's going to continue to accelerate. It's really diversifying too, because what's happening now is these companies are sprouting up all over the place that want to be a part of the new economy. And as I've moved back into the private sector, I've been approached by various companies that never thought about space before, who are now saying, hey, we want a piece of the pie. We have investors, a group of investors that are talking to me about what is it that they should be looking at, right, in terms of what areas, could they move their investment funds to in the space realm. So it's a lot happening. And then when you blend all of that with traditional aviation, you've got a lot going on. We have hypersonic. We have space balloons now where you can, pay a hefty price to go up in a balloon. Will take you in excess of 100,000 feet. It takes about 4 or 5 hours to go up and 4 or 5 hours to come down. It's basically a flying living room, and you get to see the curvature of the Earth from a balloon, a very quiet, peaceful balloon. And then, of course, all the technologies that are coming in and what's happening in space. If you don't understand why zero gravity is important to you, look at what companies like Varda and others are doing to ensure that they're doing incredible science work in zero gravity that you can't do on Earth, or you can do on Earth. It's a lot more expensive. Doing a lot of things in zero gravity, especially in the medical field, has been really beneficial. So there's a lot going on with that. We have space-based capabilities. We have the ability to refuel. You'll see SpaceX talking about how they're going to refuel their starships in orbit. And then, of course, what space is doing for weather as well. So that's been a real plus. Look at these numbers. So the annual number of objects launched into space, going back from the very first object, was a Sputnik in 1957. The United States tried to launch one right after that, and it was jokingly termed as Flopnik because the rocket exploded on the pad. But then through the 70s and 80s, it was predominantly military, right? United States, Russia, and then, of course, China is coming on as well. France, Japan, India, and European Space Agency are now into it now as well. But the United States, by anyone else, far exceeds the number of objects launched into space compared to the rest of the world. And, SpaceX themselves are probably a good piece of that number, with a launch about every 2 days now through the Falcon 9 rocket, and then the Starship Super Heavy, which just launched last week. U.S. operations. Now, this slide's a little old, but you get the idea, right? From 2014 all the way through. Right now, today, we are at 131 launches. 131. We estimated that we get 158 commercial launches by the end of the year. I think we're on track to exceed that. That is an exponential rise in launches. The reentry is a smaller bar, the light blue one. We always have less reentries than we do launches for lots of different reasons. I think you're going to see reentries going to go up, and I also think you're going to see horizontal launches go up as well. Now, this chart includes both horizontal and vertical, but the vast majority of the launches right now, the commercial space market, is on vertical rockets, and that's where it seems to be really hot right now. But I think what you'll find is that companies like Stratolaunch and others are finding shares in the market and getting their own horizontal vehicles in orbit as well. So you'll see that go up, and this chart for 26 is going to be even higher. It's going to be exponential as it goes. Payloads in orbit, you can see the changes here as well. There are a lot of things in orbit. I mean, all this is good news for the world to have a great space economy, but there's a lot of stuff up there. There's low Earth orbit, where the majority of the vehicles go. That's where the space shuttle went. The International Space Station and others are mostly in the low Earth orbit area. Then medium Earth orbit, and then the high Earth orbit above geostationary. Geostationary is getting crowded too on the equator as well. A lot of objects in space, and then there will be a business to track these as well, as the Air Force and Space Force try to push that off onto the private sector to track many objects. So the military will still track their own version, but is certainly a need for collision avoidance and protection of data, protection of vehicles in space. And with the amount of vehicles and debris, there are needs for orders or rules that would prevent people from polluting space, or maybe a requirement to get things out of orbit. So we're talking about that, trying to figure out what that's going to look like in the future. And then we have the spaceports, and here they are. Right now, there's 14 of them. Not all of them are active, but many of them are private. The three big ones I call the big three: Cape Canaveral and Kennedy Space Center, Vandenberg Space Force Base out in California, and then Wallops right here in Virginia, are probably the ones that we would call the federal range, right? Those are operated by Space Force and NASA, and they are catching the majority of the operations. In fact, Cape Canaveral is probably 70% or 80%. Vandenberg a good number, and then Wallops a small percentage of that. The rest of them are separate from the federal government. For example, Pacific Spaceport Complex in Alaska. There's Mojave Spaceport that I went to last year. That's where Stratolaunch has the Rock, which is the world's largest aircraft that launches their Talon. They're doing hypersonic work for Space Force, the United States Air Force as well. And so the Rock is stationed there at Mojave. Spaceport America, you may have heard about that one as well. And then we can't forget about the SpaceX side of Boca Chica, where the 400-foot tall Starship Super Heavy launches from. Had Flight 9 just took off there a week ago. What ended in what I would call a double mishap. Both the first stage and the second stage both resulted in mishaps, but still successful in lots of other ways. And by the way, the Starship Super Heavy rocket is 400 feet tall, 17 million pounds of thrust, and there's another version that's even bigger that's coming, 478 feet tall. If you can imagine, and 30 foot in diameter, it is an enormous vehicle. It will change for everybody when they do get it launched and operating normally. It will support the Artemis program to the moon, and it will, as Elon Musk says, they want to take it to Mars and beyond as well. The other space sites are not as active. Colorado Air and Spaceport, it's at Front Range, just to the southeast of Denver. And then you have Oklahoma Spaceport as well, and others scattered across. Blue Origin launches out of their site, West Texas. They're pretty busy as well. And then we have Cecil up in Florida, and then Space Coast, Florida as well, right near Cape Canaveral as well. So a lot of space sites, not all are busy. I think there's room to grow. Certainly on the horizontal side, I think you'll see that. All right, so here's AST, Commercial Space Transportation. A lot of people don't realize that there actually is an office in the FAA that regulates commercial space, and it's under Title 51. Most of aviation's under Title 49, and Title 51 is really for NASA and space operations. And so there's this little tiny office inside the FAA called the Office of Commercial Space Transportation. It's part of the FAA, part of the DOT, has this authority to license launches and reentries. So they also have the authority to promote, which is something that was taken out of the FAA's charge by Congress back in the 90s, because the thought was that we were promoting and still having accidents, so they didn't want to use that term anymore. But on the space side, it's there, and the FAA's job in that realm is to protect the public, property, national security, and foreign policy interests of the United States for launch and reentry. And think of it this way: we regulate the up, we regulate the down, but we don't regulate the around so much, right? So orbit is not regulated too much. NASA puts a lot of vehicles in space, and they have their own requirements. NOAA will require regulations and have regulations for anything that's a camera that looks back at the Earth. Remote sensing, they will regulate that, and the FCC will regulate the radios on a vehicle in space. But that's about the extent of on-orbit requirements right now. So you're going to see a lot of growth, I think, in that area as more and more vehicles go in space and more need to comply with the Outer Space Treaty to have regulations that kind of like ICAO does for aviation. Some standards for space are certainly needed. So we encourage, we facilitate, and we promote commercial space. And that number there says 700 launches. I think we're over 900 now in terms of total launches around, with no public casualties or major property damage. So the FAA license a launch, and they explode or blow up or have a problem, but the FAA's job is make sure nobody gets hurt, and they've done a really good job at that. So look at the space program as three different sectors, right? You got civil, which would be NASA. You have the military, which is the Air Force, Space Force, and the other branches that are involved in space, and then you have the commercial side. And sometimes the lines between these three sectors are blurring, and they are. You can have a NASA paid for vehicle with a DoD or NASA range with a DoD payload on a commercial rocket. You have all three involved in a launch, and we found that we have to work together to make it happen. So the commercial sector started way back in 1984. A lot of people didn't know that. So it's not really considered a new entrant like drones or urban air mobility, where you have electric Uber aircraft or people like that. This has been around for quite some time. The Commercial Space Act of 1984 got it started, and it was installed inside the Department of Transportation, and then became part of the FAA back in the 90s. The FAA has multiple lines of business. Looks like there's 6 lines of business that are, 5 lines of business that are the main core of what the FAA does, and commercial space is one of those. I've served in the Office of Aviation Safety and the Office of Airports, and I did the oversight of the Air Traffic Organization. So I get a pretty good view of how the FAA operates in the space realm and what their mission is. The Office of Commercial Space Transportation is by far the smallest office, but they have a huge impact. So the Commercial Space Launch Amendments Act came about in 1984. They added re-entry in 1998, because originally it was just about launches, and now it's also launch and re-entry. And then the 2004 update yet again for human spaceflight. And then there is a moratorium, by the way, against the FAA regulating human spaceflight, which has been extended past 2024 now for several more years. So the FAA will not regulate human spaceflight for quite some time, and that is a request of Congress so that the industry can grow. They call it a learning period. I do think, though, that will change if there's an accident with fatalities. The FAA will regulate quickly. I think Congress will step in fairly quickly if that happens. And the industry is being encouraged to regulate and come up with some standards. So the Commercial Space Launch Competitive Act is also coming out, and that's added some terminology. You have what is an astronaut? If somebody's flying in a rocket and they are not trained and they're just sitting there as a passenger on an automated vehicle, are they really an astronaut? And versus what a government astronaut is. A NASA paid for, trained, astronaut usually are pilots or mission specialists and things like that. So the definition was added there, and certainly more information on how we handle liability claims and all that was added in 2015 as well. Okay, the authority is interesting. The FAA's authority in commercial space actually comes on aeronautics and space under Title 14, Title 51 of 14 CFR. So you'll see that commercial space is the 400 series, and there's about, over a dozen regulations that the FAA commercial space owns. You see NASA in there and the aviation regulation. You might recognize some of those if you're a pilot as well. So that's where their authorities come from. And there's a big difference between what the FAA does with aviation and what happens with space. I mean, aviation is just immensely huge. 28,000 commercial flights a day, 540 some odd certificated commercial airports versus 14 spaceports. Here's one thing that a lot of people don't know. It's in red there. The FAA does regulate vehicles for aircraft, right? If you're flying on a United Airlines, the aircraft you're flying is certificated by the FAA. But if you go up in a Blue Origin rocket, the FAA does not certify launch and reentry vehicles. We only certify the launch and reentry operation. That's the difference. And you can make a comparison to that submarine that imploded over the Titanic was about a year ago, right? That was an unregulated vehicle that imploded and killed the people that were on board. But the owner of that vehicle said that vehicle was built above standard and it was made of composite. So that opened the eyes of the space industry because, we're putting people up in orbit right now who do not have certificated vehicles that they're going up in. They sign a letter of knowledge, knowing that there's an issue, informed consent, that there could be safety issues, and we have to share those with those people, or the owners do. And then they go up. So there's not much regulation there. But in terms of protecting the public, the FAA will do that in terms of the license for the launch and the reentry. A lot of different types of activity. We've got commercial launch and reentry vehicles that are expendable, reusable, air-launched. The lower right is the Pegasus. You may have been familiar with that. And then you have Virgin Galactic, and then the verticals. And of course, experimental permits, we issue those with the agency as well. Spaceport licenses, each spaceport has a license and must have an ability to have a license in order to launch or have reentries. Reentries don't happen normally at the vertical launch site. Usually they're in the areas like White Sands or UTTR out in Nevada or out in the ocean somewhere. And we also do the payload reviews in the FAA. That's important too, because every vehicle that puts up a payload, there's got to be a review to make sure that it's number one, what it's supposed to be, and that it doesn't impact the United States in a negative way. All right, so here are all the players. I tried to name as many as I could. There's so many to name. There's dozens of them, and they're coming in every day. SpaceX is the big one. Blue Origin, Rocket Lab, and then you have this whole setup of satellite operators that are out there as well. There's a whole industry of satellite manufacturing, and there's a whole industry that's out there that's providing the technology for satellites that's out there as well. Then you have the space tourism. Those are the balloons. Those are the Blue Origin rockets. We have one company that's building what they're going to think will be the replacement to the International Space Station in 2030. And then there's a whole bunch of work going on in orbital services and infrastructure, in-space manufacturing, in-space repair, mining for materials and asteroids, you name it. We even had somebody come to us wanting to put coffins in space, which we readily said no to, but that did happen. All right, research, microgravity, we talked about that earlier. And the players, NASA, Air Force, Space Force, Department of Commerce with NOAA, and then the FCC for the frequencies, and of course, on top of what the DOT does as well. They all work pretty well together. If the company is incorporated in the U.S. or if they're flying anywhere in the world in a U.S. company, then they'll have to get a license from the FAA. And in order to launch and re-enter, they must have that license. And if a foreign entity wants to come to the United States, they need to get one from the U.S. as well, or they can get an experimental permit as well. And that's how it works. So we don't issue license for re-entries for government and government-only launches. For example, the United States Air Force purchases a rocket vehicle and it's strictly a government mission, the FAA will not give it a license. It's considered a government launch. They assume all the liability. The FAA will coordinate the airspace, of course, but they don't issue the license for that. So when NASA and the DoD conduct their own launches, that's usually what happens with that. And then the licenses, now these are the parts. 420 is the launch site itself. Re-entry sites are also licensed. 450 is the big one that launch operators really care about because that's the one that gets them to space and back. I like to say, you know, rocket companies, they should really be licensed companies first because you can't go to space with the greatest rocket in the world until you get the license first. Part 450 is the key to that, right? And it's a new license. It's performance-based. A new regulation is performance-based. So there's no specifics to say, here's what you have to do. It's concepts that need to be addressed, and the engineers have to agree that they've addressed those. And without standards, that could be challenging. So 450 is a challenge in some ways. You don't have to worry about the terms. It won't be a test later. Spaceport licenses, Part 420 will do that. You could see those here. The reentry sites are under Part 433. And you can see Spaceport America, Cape Canaveral there in the middle. The NASA's shuttle landing facility is there. That's that 15-mile long runway in Florida, not too far from me as well. And then the far right picture is Wallops, Virginia. So for the airspace integration, it's great to put a rocket in space, but you got to work with the FAA to get the vehicles up, right? So the license and permitting process is done, and then they got to talk to the FAA air traffic about when and how they're going to launch and where they're going to launch from. Notice that most of the vertical launch sites are near the water, right? For lots of reasons, to keep the public safe, get that hazard out over the water is much more easier to deal with. But there's still very busy routes over Florida. So when a launch goes off Cape Canaveral, there is a disruption in commercial aircraft. And when Starship Super Heavy takes off from Texas, there's a disruption all across the Caribbean because we want to clear the aircraft hazard area should something go wrong. And that's all done through a letter of agreement with the FAA's air traffic system. And they provide that service to the operators. So the timelines are all in the agreement, and they've got to work that. The FAA will look at the hazards, how long your vehicle is going to be in the area, inform the operator of what kind of restrictions there are. Then they'll develop an airspace management plan. They distribute the plan to all the facilities, including in the air traffic facilities. And a lot of this is international coordination because many of these vehicles are going out over the ocean, or the Caribbean specifically, and requires a lot of coordination, or even Europe if it's a northeast trajectory, a lot of coordination with other countries. So it's a lot of work. The FAA and the operator execute their plans. It's real time. They do the restrictions. The FAA monitors the progress, and then the FAA will lift the restrictions as soon as possible so that we can return the NAS, or the National Airspace System, back to normalcy as soon as possible. Here's some information on space-based technologies. This is where the revolution is going to come. You've seen it if you're driving in your car and you're operating Waze, or you're using any form of GPS, or something that using GPS guidance coming from space, real-time tracking coming from space. How do you protect that? One of the things we haven't talked a lot about in this industry is cyber protection, where GPS signals could be jammed, where cyber can affect vehicles on orbit, navigational signals, because aircraft use these for navigation now. But certainly the terrain awareness, the information that comes in from these space-based systems affects us in everything we do, everywhere we go. Lessons learned. This is a big deal, right? We want to get the government and industry to work together. We work a lot with them on safety management systems, voluntary reporting systems. The industry's coming together to talk about that. The only problem is that the government doesn't protect voluntary reporting like they do on the aviation side. So the Congress needs to offer that protection, and I think you'll see these space companies share more once they get voluntary safety data reporting protection. In other words, free from FOIA requests. A Freedom of Information Act would require companies to give away proprietary information that they don't want to give up, so they don't want to play unless they get their data protected. That's happening on the aviation side. I think the FAA is working hard to get it done on the space side. Information sharing as well. Some ways the space industry is 100 years ahead in terms of technology than aviation. I mean, they're just so far ahead in so many ways. And in other ways, they're 100 years behind because the industry is so young. They don't really know what it's like to work together. They don't understand why it's important to work together because they don't understand that they are really an industry. They're more of myopic companies that are really focused on high-tech stuff, and they're strong competitors, but they haven't learned the lessons of the aviation side yet. And that's unfortunate. We want them to learn that before incidents happen. And they're starting to come around because they realize that as more commercial space operations occur, there's more impact to the system. The aviation side has got to be more accepting. And they're going to ask a couple questions. Are you paying into the system like we are? Number one. Number two, are you as safe as we are? As you come into the system, and that will drive them to come together, I think, and I think you'll see that happen. So a lot of former aviation sector personnel are moving into space, like me as well. Numerous benefits of building the bridge between both. I speak both languages, aviation and space, and I think that's really great to be able to do that. Industry cadence is going up and up. There's a dual mandate, right, for FAA to protect the public, but encourage at the same time. We authorize the space operations, but we don't certify the vehicles. The FAA does not authorize military launches and reentries. That Title 51 is very specific to space, not aviation, but it's weird because the FAA is an aviation agency. Commercial operations that need FAA authorization, regardless of any site in the world. So we talked about that. Human space site is a moratorium. I would change that number to the end of 26 or even 27 now. Moratorium is still going. The Part 450 rule is back and it's in publication and people are using it now. And it's safe. Commercial space has been remarkably safe, knock on wood. There hasn't been major issues with the general public getting hurt. We did have some debris come down over the Caribbean during one of the SpaceX launches, but I think the last two so far, no issues with that. And the collective risk management has been very careful as well. So we got good time for Q&A, so I will try to stop sharing here and turn it back over to you guys.
Thank you very much, Mike. Appreciate that update and information on all of those different things. Anyone here in the room got any questions for Mike? I guess you got one. Yes, ma'am.
Hi, I'm Christina Brody. I'm new, but I teach astronomy in high school.
Okay.
And I mean, what kind of things should my students be thinking about for careers if they're interested in space? And are we really going to mine asteroids too? I've seen articles about that, and I have a degree in geology too, so makes sense. But my students are always like, but how would you bring it back? Wouldn't you lose more money than you'd gain? So I guess I have two questions.
Yeah, they're excellent questions. So number one, STEM is big, right? Science, technology, engineering, math, all those courses are really critical. And we're always talking about STEM and getting students to take, science classes, engineering, mathematics, I think is super important. So those kinds of degree programs, I think, are going to pay off. Universities are starting space programs. Embry-Riddle started one recently, and I'm a adjunct professor for Embry-Riddle Aeronautical University. They just started their own space degree program. University of North Dakota has done so as well. They're an aviation school. So there's lots of interest, and it's a really growing market, but certainly science, math as well are important. And as far as mining asteroids, I've done a little bit of research on this, and I asked the same question. I mean, the asteroid belt is pretty far out there, right? So if you go there, if you find a rock that's got, 50 trillion tons of, some unique mineral that is very scarce on Earth, and bring it back, a couple pounds could be worth billions of dollars in the United States, around the world. So it's going to be driven by the market. And if they can make it work to get there at a reasonable cost and bring back something that can have benefit on Earth that makes it economically viable, then it'll work. But it's got to be some kind of a rare earth element that doesn't occur much on Earth, but it's plentiful in the asteroid belt. I forget what the material is, but the number that this one asteroid is worth, it's in the quadrillions.
Oh, is it Psyche? It's all platinum, or is that a different one?
Yeah, I don't know which one it is. I forgot the name of it, but that sounds familiar, actually.
Mission, the Psyche mission that's going on right now that NASA sent out there, because it's a metal asteroid, and that's one. But also there's 15,000 known asteroids in the same orbit as Earth, and people are paying more attention to the fact they're nearby.
Yeah.
And that's what commercial space, some of them are talking about doing. But anyway, I'm sorry.
They're like a little more accessible, maybe
Yeah,
relatively.
they're well a little closer.
Closer than the asteroid belt.
Yeah,
Okay.
it's like 7 years to get out there with the current mission and trying to get out to Psyche, which is the name of the asteroid and the mission.
Yeah. Okay.
So,
Okay. That makes sense. All right.
yeah.
There's a promise in there somewhere, right, Woody? I mean, there's a lot of talk about it. I mean, getting out there at a reasonable cost and making it worthwhile, I think financially is going to be.
Getting out in any place in space, and that's relatively close. We don't have the capability to do it. That's what we're trying to figure out. And the other part is that they're doing laser communication. NASA is back from that spacecraft. Again, you got to be able to communicate, and there's a limited amount you can do in radio. And so that's why SpaceX uses on their Starlinks lasers to communicate with all of theirs, because there's a limit on how much you can do. But so, those are all interesting stuff. Your students would find all this stuff very, very interesting.
Mm-hmm.
Anything else in the room? I'm sorry.
Yes.
I know Tom got one more person online, at least one. Jose, I think you're up.
Okay, thank you. Good afternoon, Mike. Got a question on what you said about FAA does not regulate the re-entry and re-entry vehicles coming up and down space. So so my question is this: eventually the low average is going to catch up, and a manned vehicle is going to have an accident. So my question is, at that point, who has the authority and responsibility to investigate?
Good question. So the FAA and the NTSB just signed a memorandum of agreement about 1.5 years ago now, where we address that very question. And it depends, like everything else in aviation space, it depends on the specifics of the accident. If it's considered a major accident with fatalities, that would immediately divert over to the NTSB as the lead. If it was an accident with no fatalities, or there was very little chance that someone could have gotten killed, then the FAA would retain that. So, for example, the last number of mishaps at Starship Super Heavy, the FAA has led all those investigations. Now, Super Heavy, God forbid, killed somebody on the ground in the Caribbean somewhere, the NTSB would lead that, and the FAA would be secondary, as we are currently now on the aviation side for fatals. So that's how we do it. It's with a memorandum, and it was a long time coming. Congress had a lot of interest in it, and when it was signed into agreement, it made big news, and folks were happy that that was finally codified.
Okay, thank you very much.
Okay, it's like we have another question here in the room.
You can hear me, but so how is your team, or what is the landscape right now with the evolving competition, considering like international competition for licensing and claiming territory? But how are you all preparing for that international front?
Oh, it's an excellent question. You know, there are a number of countries that are interested in launching inside the United States, and which is good and bad, right? It's good that they want to come, and it's kind of like, think about how aviation started. The first international flight that came to the United States was like, hey, what are they doing here? Well, you know, now it's regular operations. So it's good. More competition is better, right? I think having more operators is going to drive the price down. But when you talk to folks in the industry, specifically with NASA and the DoD, they're concerned about U.S. firms. They want to make sure U.S. firms are strong and are doing well before they open the floodgates for everybody, right? So, which I think makes sense. So there's a couple of different schools of thought. But what is a bigger threat is China. China is the bigger threat because what they're doing, they're not playing by the same rules, by the way. And they don't care if they trash space, by the way. And they have one goal in mind, and that is to replace the United States. So that is, you know, driving, I think, the government to really look at how we're growing the business. And by the way, China can't even compete with the United States. Nobody can. You could add the whole world together, and they don't compete with the United States on the commercial side. China really doesn't have a commercial operation because it's mostly, you know, all owned by the government anyway. They call it commercial, but is it really? But they are putting up a lot of vehicles in space, and they are wanting to catch up. The other countries that we've worked with in government are our allies, the Five Eyes, right? So England and Canada and Australia and others are really close to the United States, close allies. Italy's got interest in launching here as well. New Zealand has a company now that they've opened up in the United States called Rocket Lab, which is, you know, we do U.S. launches now from New Zealand, but they're under a U.S. license. So I think you're going to see, this is where we're like 100 years behind. This is where you're going to see the growth go, where industry is really going to realize there's money to be made by saying yes to foreign operators. And by the way, if we license a foreign operator to put up a vehicle in the United States, we get to see what's on it, on the payload, because the payload review is part of that process. Is if they go to another country and launch, the United States has no visibility into what they're putting into space. So there's benefits on the national security side as well as the economic side. If you talk to the spaceports, they love the idea of bringing international in. But if you talk to, you know, U.S. space companies that are already here, wait a minute, we can handle this, you know. And so this is something that's got to be vetted out between, you know, the users of the industry, knowing that it's going to grow, knowing that you're going to get demand to go through the roof. And eventually, I think it's going to go the same way as aviation, where it's going to be, everything's going to be, you know, standardized and kind of like a KO. So did that answer your question?
It did perfectly. Thank you.
Okay. Yes, sir.
What about using satellites to verify day-to-day events that happen in public on the Earth's surface? Like there was a hit and run accident that killed somebody a couple of years ago. They don't know anything about it yet. Is there any potential?
I think if there's a market for it, it'll happen. We already have Earth observation satellites now, like Landsat and other companies that sell, you know, really good, high quality imagery of the planet, right? But NOAA is required to license that operation, and the reason why NOAA is required to license that operation is for national security concerns, right? So, who's putting what in space, and what capability does it have? And if it's got really good capability to look at U.S. military installations is going to get their attention, right? So NOAA is going to be involved with that, as is FCC, because the radio frequencies are involved with that as well. But again, this is going to be market driven like everything else, where if there is someone's willing to pay for it, right, for that imagery, and it could be realtors that are interested in it too, right? Here's a real-time picture of the property that you want to buy. Here's where the car was parked in the lot, 2 hours ago. This is over time what kind of activity is happening there. If there's a market for it, it'll grow into that. But then you run into privacy concerns, right? Is there a reasonable expectation of privacy if you're in your backyard, right? And this is the same thing with drones, by the way, too. If you're in your backyard and satellites overhead, I don't know if there's reasonable expectation of privacy. The satellite's 100 miles up, but now they can zoom in and tell you, what's on your soda can, and then put it out for the whole world to see, if anyone's willing to pay for that. But the privacy concerns are out there as well. The benefit versus the cost is going to have to play into that as well. So if we have the ability to see everything, that's great. But think about every road and intersection across the United States. There's 2 million miles of roads in the United States. That's going to take a lot of imagery. And it's going to take a lot of information. So what would you do? Zoom in on certain intersections to get this information? I think it's possible. I think eventually we're going to get there. Because if you look at the low Earth orbit satellite constellations, there's going to be tens of thousands of them, maybe hundreds of thousands of them at some point. It may come to a point where this becomes affordable and reasonable to say, we got real-time satellite information. I could see where my car is right now, real time. That's probably not too far out into the future, as long as there's a market that supports it and people are willing to pay for it.
Okay, more, yes, sir.
Can you share a little bit more about the collaboration between the FAA, the DoD, and the commercial industries? And I guess, does the government play a role in all launches then through the FAA, even all commercial launches?
All commercial, yes. It's a very close knit relationship, because a lot of the launches happen from a federal range. Most of 70 to 80% of launches happen in Cape Canaveral. So NASA's involved because they own the range. Space Force is involved because they control the range. Commercial Space Office and FAA is involved because they license the commercial vehicle. So yeah, intricately involved, so much so that they've created a common standards working group to vet out standard issues that we all have between NASA, FAA, and the DoD, to work out, whatever the issue is. It could be safety related. It could be, you name it, how we approve and launch operation in a range, what the requirements are, those sorts of things. So they work very closely together. And like I said, the lines are almost blurred, and you almost have, many launches have all three very much involved with it. And a lot of times what you'll see is a poaching of staff between Space Force, NASA, FAA, commercial space. A lot of people go from one to the other, to the other, to the other, or they'll go to industry and then they'll come back to a different government agency. And so it's kind of incestuous in a way, but it's good because you need that talent. And it may come to the point where there's a separate agency that does this, right? There's talk of doing this, right? You would have NASA would handle all the civil, exploration stuff. But maybe there's another agency that would handle NOAA, FCC, FAA, and the commercial world, and it would be a dedicated agency, a one-stop shop for all of those. And there's been talk of that, and there is talk of moving commercial space back to the DOT. There's talk of creating a commercial space agency that would combine, a lot of these resources into one agency coming, and that may happen at some point.
Thank you for that. It's interesting to hear how the commercial industry is supported by the government in its whole.
Yeah, but that's how the airline started. And you go back, and this is another example of 100 years, right? 100 years ago, the Airmail Act of 1925 created the modern day airlines. Without the Airmail Act of 1925, you wouldn't have United Airlines. The Airmail Act got the commercial industry going. and it was government contracts, just like SpaceX is getting government contracts today, and others are too. So it's a parallel universe, right? The commercial is being right now funded mostly by needs of the government, right? But eventually, it's going to be the commercial is going to take over, and the needs of the government are going to shrink as the needs of the commercial are going to continue to grow. But it's a lot like we were in 1925. Even the regulatory structure is as sparse now as it was in 1925. The Air Commerce Act in 1926 came about because of the accidents that happened in 1925, right? Because it grew so fast. And then the Civil Aeronautics Act of 1938 grew too because it was there. So we're kind of like, in some ways, 100 years behind with the regulatory oversight of all of that. But certainly, you know, the contracts, we are the same place where we were in the 20s on the space side.
That makes a lot of sense. I can see the parallels now that you mentioned all that. Thank you.
Yeah, I've got another question in the room.
So I just wanted to get your personal thought on, you know, in some ways, the current administration is pushing for commercial, it seems to me that they're pushing for commercial spaceflight and supporting all that. But on the other hand, we're getting a lot of government cuts, particularly in the FAA. So I was wondering what your thoughts were in terms of how this administration is doing in terms of fostering a healthy commercial space industry.
Yeah. You know, that comes up a lot. I mean, that came up a lot when I was in FAA active. And right now, you know, I'm technically still an FAA employee until the end of September. So I have to be careful what I say. But even if I wasn't an FAA employee, I would still say the same thing. Everybody sees the benefit of a strong commercial operation. And this administration saw it. The last administration saw it. It was just a matter of how much attention it would get. You know, when Elon Musk joined forces with Trump, that was an interesting dynamic inside the FAA. We weren't sure where it was going to go. There was a lot of worry, but, you know, I think deep down inside, I knew I didn't have to worry because there's too much at stake for us to mess it up. I think that everybody understands that. And so, you know, if you look at the launches, they're happening just as fast as we said they would, or even faster. We're right on schedule. We're even beyond the schedule of what we forecasted a year ago. And I think that's really key. So I think it doesn't matter whether you're, you know, which side of the aisle the congressmen are in. I think everybody sees why it's important. And safety is a big deal too. I think the big worry I have is the emphasis of the industry on the regulators, right? The emphasis that the industry has on the regulators to pressure them to say yes to something that maybe they shouldn't say yes to. That's happened with the 737 MAX. It's happened with other, you know, parts of industries all across, you know, U.S. history and the world too. I think that's something that we have to be on guard for, no matter where you are, whatever administration you're in. Pressure from industry to say yes, because they want to go, and they sometimes see the government as in the way. But there's a reason why the government's in the way, and it's because it's for your safety. So I think that, you know, we're in a good place though, because it's an easy sell. People understand why it's important. They understand why the launches need to happen. We understand why you got to sit on the ground in Atlanta for an extra half hour because the route over Florida is shut down because a rocket's going to go off. People are, oh, okay, I get it. But eventually it's going to come to a point where we got to find a better way to do business. To make sure that we're integrating everything safely, because I think the safety is going to be key. If we do this wrong and somebody gets hurt, they're going to slow things down and the industry is going to suffer. And I think that's the key. You know, it's keep the focus on safety no matter who is in charge. And that's really, you know, that's the FAA's focus. I could tell you when I was in, doesn't matter who's running the show. Our job is safety, and safety is number one. And they know that. And I think that's, you know, it's an easy sell.
Yeah, safety is really my primary concern when it comes to sort of the future of space industry, because Elon has said a few problematic things in that regard. He doesn't seem to care too much about safety regulations. He seems to want to deregulate that industry, that part of things. And I've read articles sort of along those same lines, is that NASA is far too regulated in terms of its safety.
Yeah. Yeah, I mean, well, he's moving so fast too, you know. You know, I've met Elon. He came to see us about a year and a half ago. I can tell you, he's a brilliant man. Number one. Number two, he understands the safety role the agency has. I think, you know, there was some probably legitimate criticism the agency gets from all, and I've been a regulator for a long time. Legitimate criticism the agency gets because it just takes too long. You know, you're in the way, you're slowing down progress, you're taking too long, being too careful. I think the agency's probably been guilty of that. You know, because we're just err on the side of safety, just say no, don't rush it, don't do it too right. And industry's saying the longer you take, the worse it's going to be for everybody, and you're actually making it worse, not better. You know, and that was his argument. You're making it worse, not better. And China's going to beat us because you're taking too long. And the Hill was hearing that, and you know, we went back and looked and said, yeah, we do need to move faster, but we need to do it safely. But only way you can do that is to work closely with the industry and government. They got to work together. This is a lesson we learned in aviation, 30 years ago. Got to work together to make it happen, and have standards. Right now, part of what's missing is standards. So it's more of interpretation right now because we don't have standards yet. And that's something that's going to grow over time. And as we get more standards, I think the expectation is going to be, all right, here's the standard. Because right now it's opinions of engineers on both sides, and they have to agree. And I think that's really where the frustration is. But as standards grow and we get more standards in, I think that will help.
Thank you. Any other questions here in the room? Online, do we have anything else? Nothing is showing on my end, but I've got 40 people out there. So, okay. Well, I guess we're coming to the end then. Mike, we very much appreciate your time. Thank you for the insights on all of this stuff. Come visit with us sometime. See you at Sky Meadows again sometime, I hope. And and I know the people here at George Mason have a lot of things going on in this area, but they're different all their students and stuff. So I'm sure that they would like to maybe check with you. Last person was our sponsor from George Mason, who's here tonight as well. Dory, do you have something? You saying something? Push your button. Anyway.
I'm not so good on Google Meet. It's great to see you, Mike. We miss you.
Good to see you, Dory.
Yeah, and I think it's true. Every day we do our best to move things forward, and we're in the last frontier. So what an exciting career to have. Whether you're going back to that other question, aerospace engineering certainly is an area. Any of the STEM fields and supporting it. And the connection with aviation will never go away, clearly. But even people who like to experiment and blow up things like LOX methane combinations, and there's just a world of opportunity for kids who can do science. And it doesn't matter whether it's math or whether it's physics or what it is. All of that is going to be really helpful in this incredible industry that is growing so very, very fast.
Got it. Well said. Well said.
Yeah, thank you very much. Look forward to seeing you back at this end, and everyone else, thank you for your time, and clear skies. We'll see you out at one of the observing sites or next month. Thank you. Good night.